This lesson is on limiting reactants. Limiting reactants are a part of stoichiometry and chemical equations. If you are unsure how to do a mass-to-mass calculation involving chemical equations, then I recommend that you look at the lesson on stoichiometry and chemical equations and review that before you do this one. In order to solve this limiting reactant problem, you will need to be familiar with the mass-to-mass calculations. Now, in order to do a stoichiometry problem, you need a balanced chemical equation, and the equation we're given is balanced. Let's read the problem and figure out what's given and what we're looking for. So it says, how many grams of nitrogen monoxide can form if 30 grams of ammonia and 40 grams of oxygen react? So looking, I see two things. I see that they have given me 30 grams of ammonia, and so I know that in my chemical equation I'm going to be using this part, this reactant ammonia. And then they also have given me 40 grams of oxygen. Now, one distinguishing thing about limiting reactant problems is that they will give you the amounts of both reactants. One of the objectives of a limiting reactant problem is to see which reactant is going to get used up first. The reactant that gets used up first is the limiting reactant, and once that reactant is gone, the reaction will stop. This problem also then asks us to find, so it gives us two things, and then it also asks us to find the grams of nitrogen monoxide. So it's asked us to find the amount of this product right here that will form. Now, water is another product, but in this case it hasn't asked us to determine anything about the water, so we will be able to ignore it. Now, when you're doing stoichiometry problems, every stoichiometry problem involves a mole ratio. And the mole ratio can be determined using the coefficients from the balanced equation. So, but in order to use a mole ratio, by even its name, it is in moles. So when we're given grams, like we were given 30 grams of ammonia and 40 grams of oxygen, I know that I'm going to have to convert those into moles to use the mole ratio. Recall, converting grams to moles uses the molar mass. So using the periodic table, I calculated that the molar mass of ammonia is 17.034 grams per mole. The molar mass of oxygen is 32 grams per mole. And because they're asking me to find the grams of nitrogen monoxide, I'll need to know that molar mass, and it's 30.01 grams per mole. As a general rule, in stoichiometry problems, if you're given or asked to find grams, you will need to know the molar mass of that substance. Now, really, a limiting reactant problem is like doing two mass-to-mass calculations and then comparing your results. So what I'm going to do first is figure out, I'm going to start with the ammonia, and I'm going to figure out how much of the NO that 30 grams of ammonia will make. So I have 30 grams of the ammonia. Now, in order to figure out how much NO, I'm going to need to use the mole ratio. So my first step, I'm going to convert grams into moles by dividing by the molar mass. I'm writing NH3 on both just to keep it straight. Now that means that the grams of NH3 will cancel with the grams of NH3. After this first step, I have moles of NH3. So since I have moles, I can multiply by the mole ratio. In the mole ratio, you will always put the mole of what you're looking for. So I'm going to take the coefficient 4 from the balanced equation. So that's 4 moles of NO. And then I'll take the 4 from the ammonia, which is 4 moles NH3. 3, and that will cancel out the moles of NH3. Now mathematically it's 4 divided by 4, so that step would not change the answer's number. And then so finally, looking at my units, I have moles of NO right now, and so if I want to go to grams, I'm going to multiply by the molar mass. That cancels out moles of NO. Now I'm going to get this first answer by plugging it into my calculator. So I'll take 30, I divide it by 17.034, that gives me the number of moles of ammonia. Then I multiply by 4 and divide by 4, which would be the same as multiplying by 1. That would give me the moles of NO, and then to find grams of NO, I multiply by the molar mass. And I get to 4 significant figures, 52.85 grams of NO. Okay, so what I just solved there is, if I have 30 grams of ammonia, that would make 52.85 grams of NO. Well, I also was told that I have of oxygen 40 grams of oxygen. So I'm going to do the same. I'm asking myself the same question. If I have 40 grams of oxygen, how many grams of NO will that make? So first I have to convert the grams of oxygen into, oops, not 16, sorry, 32. I have to convert the grams of oxygen into moles by dividing by the molar mass. Cancels out grams. Then now I have moles of oxygen, so I'll multiply by the mole ratio from the equation. Now oxygen, looking at the reaction, has a coefficient of 5, so I'll put, oops, 5 would go on the bottom, because you always put what you're given on the bottom, so it will cancel. And then I'll look at the 4 again from the NO. The moles of O2 will cancel. And then finally I'll convert to grams, just like I did in the previous problem. I'll convert to grams of NO. Moles cancel. So now solving mathematically, I get 40 divided by 32 times 4 divided by 5 times 30.01, and I get 30.01. Let me double check because that sounds funny, but I think times 30.01. Yep, this was funny. So 30.01 grams of NO. Well, now I have two different answers that I solve for NO. 30 grams of ammonia makes 52 grams, or almost 53 grams of NO. 40 grams of oxygen makes 30 grams of NO. Now the question says how many grams? What you will always do when you set it up this way is you will pick the amount that makes the smallest. The reason is because 40 grams of oxygen will only make 30 grams of NO. What happens is, at that point, the reaction would stop because all of the oxygen would be used up. It won't have a chance to get up to 52.85 that the ammonia or the NH3 would make, because at 30.01, the 40 grams of oxygen would be all used up. This amount right here, or any amount that's calculated by a chemical equation using stoichiometry, is known as the theoretical yield. It's theoretical because we use mathematics to calculate it, And so in theory, this is what we should get if everything goes right. We know that sometimes in the lab there can be mistakes, or conditions may not be correct, or a reaction may have side reactions. There's lots of things in lab that can make our reaction not go 100% to completion or have error. But on this mathematics, this theoretical yield would show us what we would make if everything in lab went correct. If you want to see how to calculate the percentage yield, which involves a similar equation to start with, then you can look at the lesson under percentage yield.